Okay, welcome everyone to our webinar, Opportunities for Enhanced Landfill Mining in the UK. Today we are joined by Dr. Stuart Wagland, Senior Lecturer in Energy and Environmental Chemistry and Deputy Director of Research based in the Centre for Climate and Environmental Protection at Cranfield University. His extensive research in enhanced landfill mining has been funded through the EPSRC and EU Horizon 2020 projects, including Smart Ground and the New Mine Marie Curie Training Network. The current Regeneratis project explores the recovery of metals from past metallurgical sites and deposits. Work as part of this project will explore methods of extracting metals from contaminated sites such as landfills. Dr. Wagland also coordinates the UK ELFM network, a growing group of private and public sector organizations working towards enabling ELFM across the UK. Today, Stuart will talk about the work of the UK ELFM to bring together leaders in land management and the environmental sector to make landfill mining a reality in the UK. As always, there will be a chance for questions at the end of the presentation, so please do submit these in the Q&A button that's just at the bottom of your screen at any point during the presentation. I will then ask these on your behalf at the end of the presentation, so feel free to put those in throughout. So thank you again so much for logging in, and I'll now hand over to Stuart.
Hi, thank you for that introduction, and good afternoon, everybody. Thank you for coming. It's an honour to see so many people interested in this topic. As mentioned, I'll talk to you about the opportunities in the UK around enhanced landfill mining, what enhanced landfill mining is, and what we've been doing to date on the topic, including the network that we've recently started. So, probably a good place to start is to understand the problem. So the reason we've become so interested in this as a sector and as a university is that there are a substantial number of landfills in the UK, around 24,000 across the UK, but around 20,000 of those in the UK, in England themselves. Most of them are closed now, but not that many of them actually had a permit. So the blue dots on the right-hand map are historical landfill sites, and these are all closed. There's a number of them around water bodies along the coastline, and so it's been well publicised that there's been a number of landfill sites which are posing a threat along eroding coastlines and to nearby water bodies. But one thing what we do understand as well is that there are a lot of resources contained within these landfill sites, and we are interested in exploring mechanisms of recovering those materials, but also to reclaim the land for development. So enhanced landfill mining is something which I think fits very nicely into the circular economy. So not as a deliberate disposal method for later on recovery, but more for reintroducing materials which have previously been lost back into the economy. Now, enhanced landfill mining embodies the whole waste to energy, waste to material, land reclamation, land restoration, and chemical feedstocks. So it can contribute to a number of the aspects on the Ellen MacArthur circular economy model you can see on the right-hand side. I've taken some issue here, but landfill is shown at the bottom there as lost, it's all done, whereas I don't believe that's the case. I think there is an opportunity to recover material back in to the circular economy to reverse that change of disposal. So enhanced landfill mining is looking at ways of doing this. So we've been working on this now for a number of years, and one of the key differences between enhanced landfill mining and what landfill mining as a broader term means. So landfill mining is typically what's in its simplest form is removing material from one landfill site and placing it somewhere else. This is going on right now in the UK, where we're remediating closed landfill sites for redevelopment of houses. But there's minimal resource recovery going on. So some metals, maybe some aggregate materials being separated, but on the whole, it is for the purpose of reclaiming land. Capturing of methane for energy purposes can, in some definitions, mean landfill mining. But enhanced landfill mining goes a lot further than that. So we're looking at a fully integrated approach of reclaiming multiple resources from a single site, reclaiming the land, and doing so in the most environmentally sustainable way. And it's so there is a key difference between what is typically known as landfill mining and what is enhanced landfill mining. So enhanced landfill mining really is bringing together the state-of-the-art technologies to try and maximise resource recovery. So when we set out looking at this, we realised that it's actually a collaborative, multidisciplinary approach. So there's lots of expertise in the land remediation and landfill management sector, but there's also a lot of expertise in resource management and resource recovery. The circular economy package across Europe embodies that, but there's lots of expertise in separation of waste components from a larger heterogeneous mix. So we've needed to bring all of that together in order to enable enhanced landfill mining. And so when we set out doing this network, we were quite surprised really in the range of industry which was interested in this topic. So during this presentation, what I will talk to you about is the formation of that network and what we've been up to and what we plan to do, but also what Cranfield, what we have been doing in terms of our research and development around this area. So wind the clock back to 2014, Cranfield joined a European enhanced landfill mining consortium, and this was around 50, 60 organisations from across Europe, mostly in Belgium, but a number of countries were represented, including the UK. So we joined that network, and we started to realise the extent of the challenge. We were successful in securing the Smart Ground project the following year, and through ELFM, there's been a number of projects emerging, and so we could see just from ourselves the benefit of being part of a big network like this, in using this to leverage funding. So since ELFM formed, we've been involved in securing over 14 million euros of funding, all around enhanced landfill mining and sustainable landfill management. So it shows you the extent of what's possible. So with Brexit on the horizon, we thought that it's a good idea to then look at a UK specific network, which is this is what we did. So we secured some funding from the Higher Education Innovation Fund to allow us to do this, and it launched last year. So these are all of the members at the moment. We've recently appointed a steering committee. We've planned out our roadmap of what we plan to do in the UK. There's been a number of separate discussions going on between certain members and the government bodies such as the Environment Agency and DEFRA. Cranfield, we've also been involved in talking to other agencies such as Ministry of Housing, Communities and Local Government, so MHCLG. So I've a slip of memory now, couldn't remember what they're called. So we've been having a chat with MHCLG, talking about the scope of the challenge. So it's not just resource recovery which brings people together in this network. It is reducing the cost of remediation of the site. It's reclaiming land for housing and industrial development. And it's also environmental protection. So some of the landfill sites in the UK are not engineered. They're built on the dilute and disperse model. So they can pose a significant risk to groundwater supplies and surrounding rivers and lakes. So by remediating the site, you are able to remove that pollution potential. So there's a whole range of interests across the network in doing this. And what we've realised we need to do is we need to pull together our expertise, understand, learn from each other, and push together in one single direction of making enhanced landfill mining a reality in the UK. So there's a link to the network website at the end of this presentation. So if anybody is interested in joining or being involved in the network, please do drop me an email. But the roadmap that we're trying to put together as part of this network is to try and de-risk the whole business case. So understanding the business opportunities in enhanced landfill mining. So the perception that we found when we started out was that landfill mining is not profitable, and of course that is largely the case for a number of the sites. But the motivation for doing enhanced landfill mining for resource recovery only isn't economical. There's a number of reasons why you want to do this, and the whole process from identifying the site through to resource recovery and then processing of the site in terms of developing houses on that site. That whole process is financially beneficial in many cases. So we've been looking at ways of identifying the sites. So previous historical landfill records are fairly limited. So we don't always understand what is in the site. So we've got to be aware of what surprises we might find when we start looking at that site. In situ processing is something that we're interested in understanding as well. So is there a way of managing the site whilst it remains closed to recover resources, or to stabilise the site ready for ex situ processing to reduce any environmental issues that we might encounter? I mean, ex situ processing, it's the same risk as well with the understanding what's in the site. Because once we start excavating material, we may find some challenging materials within the site that we're not expecting, or are in concentrations of higher than what we hoped. The key one that we're concerned about would be asbestos. So that's been widely disposed of in landfills in the past. So it's a realistic possibility that we will find asbestos in landfill sites during excavation. I'll show you some results of the work that we've done so far, and we have looked at now 11 landfill sites in the UK with samples taken from those, and our health and safety requirements are that we do test every sample for asbestos fibres, and so far looking at 11 sites we have actually never seen a positive test. So that doesn't mean to say there's no asbestos in any of these sites, but it's not as prominent as we believed it might be. As part of de-risking this business case, we want to understand how to go about achieving site permit surrender. So what would satisfy the Environment Agency and to say this site is no longer considered to be an active landfill site? So landfill owners would be keen to surrender their site licence so that they're no longer liable for the site. But in order to do that, we need to meet a number of hurdles. And then how do you obtain approval in the first place to start excavating material? And the main challenge that we've found in the network is how do we reclassify material which is classed as waste, and how do we process that to achieve end of waste? So that's a key hurdle right now. But there's a whole host of challenges involved in separating waste material from the soil that comes out of a landfill site, and recovery of metals in economically viable quantities. And one of the other projects that we've been doing is looking at the plastics that come out of a landfill site. So we've had a look at those to find out what the opportunities are. So work done to date. So we've been to a number of landfill sites now. This is becoming a very familiar scene for me. So this is one of our UK landfill sites. It's been long since closed. You can see there's gas wells on the top there. and there's even some trees being planted. So some of the closed landfill sites will do this to make the surrounding scenery look a bit nicer. But you can see the landfill wells there. So we've been on site, and we've managed to piggyback onto some of the gas well installation operations. So this piece of equipment here bores down to the bottom of a landfill site, recovering excavating a lot of material in place of installing a gas well. So we take that material away, but we manage to separate it into 1 meter depth fractions. So each one of these bags that you can see here contain 1 meter length of that bore. So we've been down to as low as 40 meters in some landfill sites. So we get a nice profile of what the waste is like in this landfill site, how much waste is degraded. It gives us a really good understanding of the composition of the material around, and allows us to look at the opportunities of resource recovery. As I mentioned before, we do a stringent testing on these materials before we start processing them. So we have sent all of these samples off for external analysis for asbestos fibres, and yet to find a positive result, which is good news for us. But it doesn't mean we can relax. We will continue to do that. So we've sorted all this material out, looking at the composition of the material, so the fine fraction, soil-like material, the plastics, paper, textile, wood, metals. We found some interesting things. So this catalogue here, you can just see, still very much legible. You can still read it, and this was from some 20 meters down in a closed landfill site. So at best guess, it's around 10 years old, and you can see it's not gone anywhere. It's just been slightly soaked through with moisture, but the paper's still there. So it just goes to show what we put in landfill sites does stay there for a long time, and it's a long-term environmental burden if left there. So I won't read out this table to you, but this is just to show a snippet of some of the information we've been able to collect from 9 of the sites. So you can see right in the middle there, organic. So that organic material is soil-like fines, material that either once organic waste or was soil layer that was used in the daily cover. It's immediately obvious that is the dominant fraction of all samples that we've extracted from landfills, and so that needs to be managed, and that poses a challenge in using conventional waste separation technologies, in that we're not used to dealing with such high levels of soil-like material. So here illustrating the same data but in a graph, that soil layer is the dominant fraction, but you can see in the plastic amount that we've managed to extract, 10-15% is a normal range for plastics. The site 5 and 6 and 7 for that matter have got relatively high concentrations of plastics in there. So we started to ask the question of what do we do with this soil layer? What is possible to do with that? Because we can't use it as soil. It's heavily contaminated. There's lots of metals in there. So we were very interested in looking at how could we extract that material from this soil layer. How can we extract the metals? And that links to the work that we're doing as part of our Regeneratis project, which is currently ongoing. And one of the projects which is now completed was looking at upcycling of plastic waste from landfills. So yet more data. This is the meter fractions. So this is 22 meter intervals, showing the range of material as you go down a landfill site. So there's no true pattern here, except that the organic fraction remains the dominant fraction. Plastics is very variable, but lots of glass and lots of metals in there as well. but some of the metals will be contained within the soil layer. So metals are mobilized in a landfill site and attach themselves to soil. So we're now interested in developing approaches for reclaiming those metals from the soil. Initially, we were interested in rare earth elements and critical materials. So these are rare earth elements mostly, but the ones of interest personally, I think, are lithium and cobalt at the end. So these are metals which are currently in demand for electric vehicles and batteries. So we're very interested now in understanding a bit more about how much is really in landfill sites. So this is only from four landfill sites this data is from. But we're interested now is any industrial landfill sites which have been receiving industrial slags and metallurgy wastes. What's the concentration of lithium and cobalt in those sites, and how do we recover them? Other areas of interest are copper, aluminium. Naturally, we did want to have a look at silver and gold, but you can see the concentration of silver and gold in these sites is fairly low. So the conclusion that we would have from this metal analysis is you wouldn't go about doing an enhanced landfill mining project just to recover a specific metal. To make the whole process viable, you would need to recover multiple metals in a single operation. And then finally, the plastics. So we found lots of plastics in these sites. So the first thing we set about doing was understanding what types of plastics are they. So there's lots of polyethylene in there, lots of polypropylene, lots of PET plastics. So we had a look at all these, but we were keen to understand the level of contamination and how degraded these plastics are. And the electron microscope pictures at the bottom there show that the compared to a fresh polypropylene, the material contained within a landfill site is degraded and it is contaminated. So it begs the question really of how viable is it to simply extract plastics from a landfill site and recycle them in the conventional sense. The answer to that is it's very difficult to justify doing that because of the cleaning required and the degradation that's already happened to the samples. So we had a detailed analysis of what's been going on at a chemical level in the polymers. We noticed that there was a significant level of degradation in polypropylene and polyethylene. One of our unexpected findings, however, which justifies the metals work that we've been doing actually. So titanium is used as a catalyst in the production of polyethylene. And so when we looked at some non-landfilled polyethylene, I say fresh polyethylene, non-landfill polyethylene, we found that the titanium content was quite high compared to material we extracted from landfill. So what we believe is happening is inside the landfill, that titanium is being mobilized through solubilized organic compounds, which are chelated and complexing with these metals and mobilizing the titanium. So in some cases, the plastic that we extracted from landfill was cleaner than the fresh, but that doesn't account for all the soil stuck to it. So there are some interesting processes going on in landfill. In terms of what we can do, we had a look at pyrolysis for chemical recycling. It's been a popular topic for processing of low-grade plastic waste. So we naturally wanted to have a look at how we could apply that process to landfill plastics. Now, a group of compounds known as naphtha is very useful, but we found that in older plastics from landfill sites, you get lower yields of that material. The kerosene range, which is useful for alternative fuels, it's still a lower yield from older plastics, but not quite so significant as in the naphtha range. But the diesel and waxes, we noticed no significant impact on yield. So there is a possibility to use chemical recycling on plastics from landfill sites. So that's a positive outcome, in that if we can try to put together a process of metal recovery and plastic recovery with chemical recycling, you start to build the case for resource recovery from a number of different angles, ultimately leading to the reclaiming of the landfill site for development. So at the bottom there, you can see the link to the network. So please have a look at that website and join if you're interested. But in terms of the opportunities across the UK, we see there has been significant opportunity to recover metals from closed landfill sites. You need to maximise the resource value from all the components to make this make the whole enhanced landfill mining project viable. We don't see it necessarily as identifying a landfill site for making a profit. If you're going to remediate the site anyway for housing development, then enhanced landfill mining could offset the costs, could actually reduce the cost of site remediation. So use selling the resources recovered to help pay for the site remediation processes. And it can actually, once it's proven, we can use it more widely, it can accelerate land reclamation and resource recovery. So I think there's a whole range of benefits for this. But thank you for your attention. And if there's any questions, I'll be very keen to answer them.
Great. Thank you so much, Stuart, for that lovely presentation. We already have some questions, so we can jump right in, I suppose. So the first one is, how can you apply to join the UK ELFM network?
Okay, so send me an email. It's no formal application process. It's more of an expression of interest. Say you're interested in joining, and I will help you do that.
Great. The next one is a long one, so I'll try and get everything right here. There is currently a huge issue with the regulation of recovery of landfill materials on construction projects. The EA recently responded to an open letter from SILC about the issue being very unhelpful in pointing to the current regulatory process of deposit for recovery, which is clunky, not suitable for development, and can take 18 months to achieve. Do you have any thoughts on how the regulation / licensing of landfill mining / recovery can be achieved painlessly?
Okay, it's an interesting question. I did actually mean to refer to that letter from the Environment Agency, which I saw like a few days ago. It's not painless at the moment. It's far from it. However, there are a number of landfill remediation sites going underway right now in the UK. So there is a possibility that in addition to doing that, you can recover more of the resources. But it's the whole challenge I mentioned earlier on in achieving end of waste, and it is painful, and this is definitely one of the challenges that we need to overcome, and that's one thing that the network is focusing on.
Wonderful. So the next one is, do your findings indicate that there is sufficient value in the recovered materials to make enhanced landfill mining viable? Or do you also need to rely on the increased land value and development opportunity to make this work?
Okay. The current feeling is that landfill sites with a higher land value become more attractive, are more attractive right now. So the land value does play a major role in making the whole process profitable. As I mentioned, however, it's not, enhanced landfill mining doesn't necessarily need to be profitable if a landfill site is going to be remediated anyway for development. The enhanced landfill mining approach can actually reduce the cost of doing the remediation in the first place. We have done some analysis of the available sites in the UK. We would put a conservative estimate of around 10% of landfill sites, I think, would be commercially viable just on resource recovery.
Wonderful. The next one is, where can you find a list of close landfills that would be available for redevelopment?
I think the only way you can do that now is to do the type of analysis that we've done, where we've got the list of all the landfill sites, and we've created a decision support tool which can look at all of those landfill sites and estimate what might be in there based on the land value as well. So, but I think this question is more for which landfill sites have been added to the development plan for local governments. Is that correct? I think.
Yeah, Sean, if you want to clarify for us, maybe we can come back to that. Great. There's another question here from Andrew. So they say, are there any soil washing techniques that you have seen that will allow for significant recovery of metals from soils? Or would something like bioaccumulating plants be the best option for recovery?
This is something we're looking at very closely right now. So the Regeneratis project, we have a number of researchers all working on this. We're looking at bioleaching, we're looking at green solvent extraction. So we're looking at a number of conventional soil washing technologies which might be viable for this. And one of the goals, I think, would be to put together a sequence of using multiple recovery processes in an integrated process to recover metals at different stages. I think it'd be so I can't answer that completely right now because we're currently looking at it.
Great. From Alex, they've asked, they said, hi, Stuart, interesting research. In terms of the industrial waste, smelter/steel slags, etc., do you think that these could be possible candidates to mine independently, i.e. without the requirement for subsequent land development?
That's an interesting question. I don't know. Because it depends how you leave the site afterwards, I suppose. So so you need to leave the site in some form of remediated state, I'd imagine. So it could be multi-party. So one company comes on and recovers the material, leaving the land remediated, ready for the developer to move on. I think that would be one mechanism of enabling that.
Okay, the next question from Claire. In order to surrender landfill permits, certain assessments are required to illustrate risk has been sufficiently reduced, e.g. gas risk assessment, groundwater risk assessment. If the historic landfills are still producing gas and leachate, sorry, this would pose a barrier to surrender. Did the EA indicate any way around this barrier? For example, enhanced landfill mining undertaken ahead of surrender?
No, the Environment Agency have not indicated that. The Environment Agency would only be supportive of license surrender if the landfill posed no further risk. So I think this question is relating to doing landfill mining ahead of that to try and accelerate the deactivation of the site, I suppose. There's been no indication of that yet. I think that would be very complex to do.
Okay, the next one is, are there any learning outcomes from enhanced landfill mining that can be used to inform the way future landfills are managed in terms of how the materials are mixed, etc., to make it easier to reuse materials?
That's an interesting question. It's actually come up with us. We've been discussing with some countries located outside of Europe who are looking at moving away from open dump sites to engineered landfill sites, and they are exploring the idea of using those as long-term storage solutions. So there are definitely some outcomes from enhanced landfill mining that we've seen along the way, but I wouldn't call them outcomes from enhanced landfill mining specifically. It's more understanding how we might do more sustainable landfilling using better engineering techniques.
Okay, the next one is, would there be a financially viable option to use unusable waste as a fuel for the likes of EFW plant rather than curbside collection to MRF to EFW?
Sorry, I'm just reading that question back. This currently happens in the UK anyway. But is this question looking at taking material from a landfill site and using that as a fuel? I think that if whoever asked that question could clarify.
Yeah, if whoever asked that, if you want to just add that to the Q&A to clarify your meaning, that would be helpful. That's all the questions we had. If anyone has any other questions, please do feel free to drop them into the Q&A. I guess while we wait for any more questions, is there any other things that you wanted to mention, Stuart, to the audience in terms of maybe other readings that they could look into on this topic or policy that might be coming up that they should keep an eye on? Oh, they've clarified for us. Yes, using landfill waste as fuel rather than using waste from a collection stream.
Oh, okay. Yeah, we have looked at that as well. So a group of our MSc students actually looked at this. So we found that the combustible fraction from landfill was around 12 megajoules per kilogram. So it is viable. The only concerns I would have is that there are lots of contaminants attached to this material, which would lead to further considerations on the corrosion in an energy from waste plant and other emissions. So yes, it's possible, but it wouldn't be an economically viable route. So if you're extracting, let's say, plastics and textiles from a landfill site, you would still need to pay between 100 and 120 pounds per tonne to send that material to an energy from waste plant. So undertaking a landfill mining project to do that, it's a significant cost. So we'd be looking at using the plastics and textiles in another way which is costing less than that, such as the chemical recycling route that I mentioned earlier.
Great. Okay, that was our last question. So if there's no other questions, I think we can wrap up and everyone can have a little bit of extra time in their day. So thank you so much, Stuart, again, for presenting. That was really informative. It sounds like people had lots of questions, so hopefully you guys got lots out of it today. So that is it for us today. So thank you so much for logging in. I hope you found that beneficial and informative. Don't forget to record your attendance at this webinar in the IES CPD tool. You can do this by logging into the members area. This webinar has been recorded and will be available on the IES website and YouTube channel. If you are watching this recording on YouTube, please do subscribe to our channel, like the video, and hit that notification bell to get updated when we post new webinars. So thank you again to Stuart for that lovely presentation, and to everyone who came today. I hope you have a lovely afternoon, and thank you for watching.